skill training video has been produced by Semker in collaboration with PSSC and CNK. This video is aligned to the job role Electrician Domestic Solutions, PSS/Q6001, QP code PSS/N6001, PSS/N6002. We are now going to learn about the types of single-phase motors used in a domestic installation. What do you mean by single-phase motors? Single-phase motors are the electrical devices with output power around 1 HP or horsepower. These are mostly single-phase induction motors. They play a vital role in domestic applications. Most of these domestic applications are fans, electric toys, blowers, centrifugal pumps, washing machines, and so on. When supplying a single-phase AC voltage to the stator winding of the single-phase induction motor, the alternating current starts flowing through the stator or main winding. This alternating current produces an alternating flux called main flux. This main flux also links with the rotor conductors and hence cut the rotor conductors. According to the Faraday's law of electromagnetic induction, EMF gets induced in the rotor. As the rotor circuit is closed on so, the current starts flowing in the rotor. This current is also called the rotor current. This rotor current produces its own flux called rotor flux. Since this flux is produced due to induction principles, so the motor working on this principle got its name as induction motor. Now there are two fluxes produce the desired torque, which is required by the motor to rotate. You are seeing ceiling fan motor in which stator winding mounted on the shaft. Stator has two winding, outer one is start winding and inner one is running winding. We provide the single-phase power supply to stator winding. Another one you're seeing, which is rotor. The rotor is the outer shell which has no coil mounted. As we know, single-phase induction motor is not self-starting. Now we will see the methods for making single-phase induction as self-starting motor. The single-phase induction motors are not self-starting because the produced stator flux is alternating in nature, and at the starting the two components of this flux cancel each other and hence there is not net torque. The solution to this problem is that if the stator flux is made rotating type rather than alternating type, which rotates in one particular direction only, then the induction motor will become self-starting. Now for producing this rotating magnetic field, we require two alternating flux, having some phase difference angle between them. When these two fluxes interact with each other, they will produce a resultant flux. This resultant flux is rotating in nature and rotates in space in one particular direction only. Once the motor starts running, then additional flux can be removed. The motor will continue to run under the influence of the main flux only. There are various methods to start these machines. Based on the methods, these are classified as split-phase motors. The split-phase motors are again classified into resistance start motors, capacitor start motors, capacitor run motors, and capacitor start capacitor run motors, and so on. Induction motor introduction. We know that an AC or alternating current motor is an electromechanical device. It converts electrical energy into mechanical movement. AC motors are at the heart of the electrical consumption in the world because they do so much with very little human intervention. The AC motor is by far the easiest and cheapest motor used in the industry. As long as they stay within their operating characteristics, they can run as long as 100 years with very little maintenance. The main parts of the AC motor are the rotor and stator. A rotor is a rotating part of the AC motor, which is supported by a set of bearings to allow flawless rotation. The bearings are pressed into the set of end balls, which are filled with a lubricant to allow fluid motion. The stator is the fixed or stationary part of the motor in which the end balls are attached. The windings are wrapped around laminated sheets of iron that creates an electromagnetic rotating field when the coil is energized. Motors are very versatile electromechanical components. This is because they can be sized, configured, and constructed to fit any situation or perform any duty. A large percentage of motors being used in industry are single-phase and three-phase motors. Types of split-phase induction motors. Depending on additional means, split-phase induction motors are classified as 1. Resistance start induction motor. In addition to the main winding or running winding, a single-phase induction motor's stator carries another winding called auxiliary winding or starting winding. A centrifugal switch is connected in series with auxiliary winding. This switch aims to disconnect the auxiliary winding from the main circuit when the motor attains a speed up to 75 to 80% of the synchronous speed. We know that the running winding is inductive in nature. We aim to create the phase difference between the two windings, and this is possible if the starting winding carries higher resistance. Applications of resistance start induction motor. Resistance start induction motors have low starting current and moderate starting torque. So these motors are used in fans, blowers, centrifugal pumps, washing machines, grinders, air conditioning fans, and so on. 2. Capacitor start induction motor and capacitor start capacitor run induction motor. In the case of a split phase induction motor, we use resistance for creating phase difference. But here we use a capacitor for this purpose. We are familiar with the fact that the current flowing through the capacitor leads to the voltage. So in capacitor start inductor motor and capacitor start capacitor run induction motor, we are using two windings, the main winding and the start winding. With starting winding, we connect a capacitor. So the current flowing in the capacitor leads to the applied voltage by some angle. The running winding is inductive in nature, so the current flowing in running winding lags behind applied voltage by an angle. Applications of capacitor start induction motor and capacitor start capacitor run induction motor. These motors have high starting torque. Hence they are used in conveyors, grinders, air conditioners, compressors, and so on. They are available up to 6 kW and above. 3. Permanent split capacitor PSC motor or single value capacitor motor. It has a cage rotor and stator. The stator has two windings, main and auxiliary winding. It has only one capacitor in series with starting winding. It has no starting switch. Advantages of permanent split capacitor motor. No centrifugal switch is needed. It has higher efficiency and pull-out torque. Applications of permanent split capacitor motor. It finds applications in fans and blowers and heaters and air conditioners. It is also used to drive office machinery. 4. Shaded pole motor. The stator of the shaded pole single-phase induction motor has salient or projected poles. These poles are shaded by a copper band or ring, which is inductive. The poles are divided into two unequal halves. The smaller portion carries the copper band and is called the shaded portion of the pole. Applications of shaded pole motor. Due to their low starting torques and reasonable cost, these motors are mostly employed in small instruments like hair dryers, toys, record players, small fans, electric clocks, and so on. These motors are usually available below 1 kW range. Now we are seeing different type of single-phase induction motor used in domestic purpose. Those are ceiling fan, water pump, blower, drill machine, and capacitor start and capacitor run starter. In capacitor run capacitor start starter, we select start capacitor of higher capacity than capacitor run capacitor. As you are seeing start capacitor capacity range between 150 to 200 microfarad and run capacitor capacity 100 microfarad.